Hello all and welcome back to this course on computer organization. So in the last couple of videos, we looked at the idea of moving data from memory or moving data from a register into another register and so on, right? However, there is another operation which is very critical to any microprocessor, and that is basically called the immediate data access. Okay, so remember I told you that we said move EAX comma EBX. This was a simple register access, right? Then we did move EAX comma contents of EBX, right? This is register indirect, right, where EBX is used as an address and then you access that address for data from that address and move it into EAX. Of course, the segment register, which is a data segment, will kick in order to calculate that address. Then we said move EAX comma EBX, let's say plus 4, right? This is register indirect with offset. Okay, now it's not always that the data that you want has to come only from the memory or from another register. It might be a constant number. So therefore, for example, I may want to do move EAX comma 0x42. Okay, what does this mean? Or if I want to explicitly make it a 32-bit number, it will be like this, 42. This is called immediate access. Why is it called immediate access? Because this 42, this whole thing is actually encoded inside that instruction. So the machine code itself contains this 0x42 and therefore it is immediately available, and therefore that data can be very easily loaded into the register for any operation, right? So these are the different kinds of register access that we would do, okay, using in the x86 architecture. So in this lecture, I would just like to maybe write a few more programs, okay, that will allow us to understand, what are the different kinds of access that we want to do. So let us do one thing. Maybe what we'll do is, I want you to, let's write a program where we initialize EAX register with equal to 0x42, EBX register with the number 69. Okay, note that this is a hexadecimal number and this is a decimal number. Okay, so the two number systems are different, but it's okay. I'm trying to highlight that we can as well do all this. Then I want to add EAX and EBX and store in ECX. Okay, this is the assembly program that I want to write. So what would I do? I would say first move EAX comma 0x42. Okay, this is an register immediate access. Then I am going to say move EBX comma 69. So remember, you can use, if you don't put the 0x, the number will get interpreted as a base 10 number. If you put the 0x, it will get interpreted as a hexadecimal number. So you could do it in either way, right? And then what do I want to do? So EAX has, so this, let me write the comment, EAX equals 0x42, EBX equals 69, okay, and then I say add EAX comma EBX. So this is important to note that when I do the addition instruction, one of the registers is going to serve as the source as well as the destination. So here EAX after this operation will get the value of 0x42 plus 69. Okay. So what is 0x42? It is 2 plus 16 into 4. So 66. So you will get 66 plus 69 as the answer. And therefore this will be what? 135. So EAX will have the value 135 stored in it after this particular operation. But remember, I want to eventually store the answer in ECX. So therefore, I have to do move ECX comma EAX. So what is on the right is the source, the left is the destination, and therefore ECX will get the value 135. Okay. Now, in the process of writing this program, we have actually overwritten the value of EAX, okay, and therefore it is important to note that that value also has changed at the end of this program. Now, suppose I also added the condition that you don't want EAX comma EBX should not change. Should remain unchanged. Okay. Now this is an interesting problem because I want EAX and EBX to have the same value, that is 0x42 and 69. EBX remains unchanged even in this program. But suppose I add this extra constraint, then I need to now work with a different register. Okay, remember that. So I say move EAX comma 0x42. So what I'll do is now I will use another register EDX comma EAX. Okay, so EAX has the value 0x42 and I have moved that to EDX, and then I do move EBX comma 69, and then I say let us add EDX comma EBX. Now in this case what has happened? EAX equals 0x42, EDX equals 0x42, EBX equals 69, and EDX will now get 0x42 plus 69 equal to 135. But note that EAX has not changed in the process. So finally I move ECX into ECX the value of EDX. So ECX is going to be exactly my value here, which is 135. Now of course, because ECX is the final destination, I could avoid the use of the extra register EDX completely. For example, here I could say please do ECX comma EAX, in which case ECX itself will get the value 0x42 in the first shot. Then instead of adding to EDX, I say ECX comma EBX. So my ECX itself will get 0x42 plus this, in which case I don't need this extra instruction here at all. And at the end of this program, ECX will have the sum of 0x42 and 69, EAX will have 0x42, and EBX will have the value 69. Okay. Now, where do you use this? So after this, for example, I may want to use EAX move it into another register and do another operation with it, right? So I don't want to lose the value of the EAX register. So for example, here if I say move or add EDX, right? Let me say move EDX comma EAX. Okay, so let's just say that, and here I'm going to now say so subtract EDX comma EBX. So in this EDX will get the value 0x42. This will get the value EDX will be this is 0x42. So this is 66 minus 69, answer will be minus 3. So this is exactly where for example I want to use EAX and do another subtraction operation with it. Then this is the best way for me to do this whole operation. Likewise, instead of getting values from a register or from immediate data, I might want to first initialize an address. Okay, so let us say the next program I want to initialize address, and I mean an offset, okay, in EAX, okay, and then I want to add 0x24 to the data sitting in the address. Okay, so what I mean is, now there is a certain address which is available as immediate data. I want to load that into a register. Then I want to add an immediate data, okay, to that particular data coming from that address, right? So what do I have? Let's say that address offset is some 0x0000 FFEE. Okay, this is my immediate data that is available, and I want to load this into a. So what do? I first move I'll choose EBX, comma 0x right, and then I'm going to say get me the data, okay, from that memory. Okay, so let's look at that. I can do move ECX, comma contents of EBX, right? So EBX will be treated as an address offset, and then you use this data segment register, calculate the address, get the data, get the value from that into ECX. Okay, and then now I want to add the immediate data 0x24 to this particular value. Okay, so ECX, comma 0x24. So I can do this immediate data even with the add operation, subtract operation, whatever, right? The register, the immediate access of data can be done even using the any ALU operation as well. So effectively what will happen here now, this offset is going to point to a certain number. Let's say that is 0x00000024. Okay, or I can effectively say this is all 0x24. Okay, so in this program my EBX will first get 0x0000 FFEE. right? Then into ECX, I am going to load a certain the data that is pointed to by this offset, which happens to be this number, and therefore you will get 0x24, right? And after that, add ECX comma or let me not, okay, both should not be 24. I'll call this 39. Okay, 39. Okay, so then I'm going to say ECX is 24 plus 0x. So 9 plus 4 is A, B, C, D, right? So you get D and 5. You'll get the answer to be 5D out here, right? So this is how simple assembly programs can be written with the data movement and the ALU operations. One interesting thing to note here is that I told you that one of the operands to any ALU operation has to be a register, right? Both of them cannot be a memory. Okay, so it's important to note this. So you cannot have, for example, add contents of EDX comma contents of ECX. This is not possible, right? You cannot treat DX and ECX and EDX as two addresses and try to read those two pieces of data, add them and put them back into the contents pointed to by EDX. This is not possible, and this is primarily because memories mostly are single port memories. You give one address, you can access one data at a given time. You want to access multiple data, then you need to do it across different clock cycles, and that is it is a different complexity. We'll come to that a little later, but for now let's assume that we are dealing with simple single port memories where at a given time you give an address, you can get a data, you read it, you do something, and then put it back and stuff like that. So that's all it is. So that's why one of the operands necessarily has to be one of the registers, general purpose registers that are sitting in your microprocessor.